The density of a gas. The density of a gas can be determined if you know the mass of the gas and the volume that that gas occupies. You can experimentally determine it because the definition of density is equal to mass divided by volume. Now, normally for a gas, the units for density are expressed in units of grams per liter. This is because densities of gases are normally about 1,000 times less than liquids and solids, which are normally expressed in units of grams per milliliter. Now, if you know the molar mass of your gas and the pressure and temperature of your gas, you can actually derive a formula for density from the ideal gas law. Let me show you how it's done. The ideal gas law, of course, is PV equals nRT. Now, density is expressed in units of mass divided by volume. Of course, in the ideal gas law, we don't have the quantity of the gas described in terms of mass, but rather number of moles. Let's rearrange the ideal gas law in terms of amount in moles divided by volume. Okay, so if we do that, if we express the ideal gas law as the amount in moles divided by volume, that's going to equal, let's see, P divided by RT. R, of course, is the gas constant, P is the pressure of the gas, and T is the temperature. Now, I want to convert this particular ideal gas law into a density expression, number of moles per volume, but I need it to be for density in the amount of mass in grams per volume. How can I do that? Well, if I multiply both sides of this equation by the molar mass of the gas, I still have the same equality. But as you know, the units for molar mass are grams per mole. The units for N are mole. So those units will cancel, and I'll be left with units of grams per liter, because volume is in units of liter, which is the same as the density of the gas. So the density of the gas can be calculated if you know the pressure of the gas, the molar mass of the gas constant, and the temperature. So we've just derived an equation for calculating from pressure, temperature, and molar mass the density of a gas. Why don't you try that?